Good morning, project committee, advisor, and professor. This project is about the cost comparison of two-story residential building design without and with seismic resistance based on the DPT standard. And this presentation is submitted in partial fulfillment of the requirement for the degree of Bachelor of Engineering, Faculty of Engineering, King Mongkut University of Technology Thonburi, and project advisor is Dr. Ekachai Yu Pasachai. On the 24th March 2011, the magnitude 6.8 earthquake occurred in Thale, Myanmar, and affected the northern province of Thailand. And many buildings and roads in Thailand suffer damage because most of them are not designed to withstand the seismic wave. And also on 5 May 2014, the magnitude 6.1 earthquake occurred near Marao, northern Thailand. This earthquake damaged and ruptures the healthcare service in the epicentral region. From the increasing severity of earthquake in Thailand, the earthquake affect the safety of people in various areas many times. So the earthquake resistant design standard for building 2018 version or DPT 1301/130261 has been published, and the materials regulation enforce related buildings to design as seismic resistant according to the DPT standard to reflect current seismic condition and information. DPT standard divides the seismic area into 3 zones as shown in the pictures. Each zone has their own building trust condition since the most important buildings such as power plants, hospital, and police station to buildings that are heavily used, especially in Zone 3, the buildings which are in land development or real estate company must be designed to resist the earthquake according to the law. According to the laws and DPT standards, we want to study how to design earthquake-resistant building and the cost comparison of two-story residential buildings designed without and with seismic resistance. Based on the DPT standard, we decide to select two-story residential buildings because the numbers of housing estates in Thailand is increasing and almost all of them have two-story.
Next, we will look into the methodology. The buildings that we use as reference are the contemporary Thai Family House 5 and Ban Araya 3 of the Department of Public Works and Town and Country Planning or DPT. In our study, the buildings will be at Kanchanaburi and Chiang Mai, which are located in Zone 3, so they must be redesigned into a seismic resistant building according to the law. In seismic analysis, the equivalent static lateral force method will be used to analyze the structure. Our study case are two-story residential buildings, so the buildings were classified as type 2 from occupancy category, and the important factor is 1. For the lateral resistance system, in this study, we consider and design the building as an intermediate RC moment resisting frame. So, according to the DPT standard, the response modification factor is 5, system overstrength factor is 3, and deflection amplification factor is 4.5. To analyze the seismic force, the spectral response acceleration or SA is different in each area. SA at a short period and 1 second of Chiang Mai is 0.963 and 0.248 in order. For SA at a short period and 1 second of Kanchanaburi is 0.642 and 0.241 respectively. Then spectral response acceleration will be modified due to the soil condition in each area. Finally, we can determine the seismic response coefficient or CS at each location. For the Chiang Mai area, the CS is equal to 13.04% of the building weight. For the Kanchanaburi area, the CS is equal to 8.7 of the building weight. The seismic response coefficient will be input into the ATHIPAT software. Then the building will be modeled and analyzed. In designing, the major points that we need to consider are beam and column designing. The seismic force will act on the building, causing the base shear at ground level. The base shear will distribute to each level of the building as a lateral force. According to the DPT standard, we need to design structural elements to resist the shear force that occur from the seismic force. The main point of the design is at the plastic hinge. These are examples of structural elements with and without seismic resistant design. As you can see, columns and beams have to increase stirrup, tie steel, the strength of concrete, and cross-section in the column to resist the seismic force. For the foundations, the site has been enlarged and increased the number of steel reinforcements and driven piles.
Next part is results and discussion. Family 5 house in the foundation. The rate of budget chains of building located at Kanchanaburi and Chiang Mai are 107.20% and 118.03% respectively. For Ban Area 3 house in the foundation construction, the rate of budget chains of buildings located at Kanchanaburi and Chiang Mai are 114.31% and 137.15% respectively. These are some examples of foundation section that we select to show you. Next is the column. Family 5 house in the column. The rate of partitions of buildings located at Kanchanaburi and Chiang Mai are 57.20% and 90.07% respectively. For Ban Area 3 house in the column construction, the rate of partitions of buildings located at Kanchanaburi and Chiang Mai are 166.89% and 191.97% respectively. These are some examples of column section that we select to show you. Next is the beam. Family 5 house in the beam. The rate of partitions of buildings located at Kanchanaburi and Chiang Mai are 25.80% and 25.80% respectively. For Ban Area 3 house, in the beam construction, the rate of partitions of buildings located at Kanchanaburi and Chiang Mai are 15.24% and 15.59% respectively. These are some examples of beam section that we select to show you. Next is overall budget estimation of both two types of house. These are the overall budget estimation of Family 5. These are the overall budget estimations of Area 3. The last part is conclusion. The study indicates that the rate of budget change of Family 5 buildings located at Kanchanaburi and Chiang Mai are 17.60% and 20.53%. The rate of budget change of Ban Area 3 building located at Kanchanaburi and Chiang Mai are 15.14% and 17.52% respectively. The column selection is larger due to the number of stirrup and longitude steel. The concrete volume and the strength of concrete are increased. The beam section is the same, but the stirrup is added and the strength of concrete is increased. The foundation is larger, which are due to the steel volume of concrete and the strength of concrete are increased. However, the price that mainly affect the increase in construction costs is the foundation. The construction budgets of buildings at Chiang Mai are more than Kanchanaburi due to the base shear at Chiang Mai being more than Kanchanaburi. The shear distribution at the base to the lateral force in each layer is greater and causes an increase in bending moment.
And this is all our final project presentations on the topic cost comparison of two-story residential building design without and with seismic resistance based on the DPT standard. If you have any question, please feel free to ask. Thank you for attention.